right, everybody, let's go over some probability that you might see on the SOL, and we want to make sure you understand it. Independent probability is the probability that one event that does not affect the outcome of the second. Okay, so if you are doing something and you see the words with replacement, or I put it back, or replaced, or if two things have absolutely nothing to do with one another, then that means it's independent probability. Now, we also have something called dependent probability. The probability of one event does affect the outcome of the second event. And you have to usually, or yes, you do, reduce the denominator by 1. So if you hear the words without replacement, or not putting back, or somebody ate a candy or a cookie, that's dependent probability. So we're going to do a few examples and let's see what we can figure out here, okay? This says that Miss Wright has a box of markers that are all the same shape and size that she uses to write on the board. There are 4 reds, 3 greens, and 8 blacks. All right, so first of all, before we do anything else, let's figure how many there are in total. All right, so I'm just going to use Desmos. It's here. I'm going to say 4 reds plus 3 greens and 8 blacks gives us a total of 15 markers. All right. What is the probability that Mrs. Wright will select a red marker, put it back in the box, and then select a green marker? Well, there's 2 things happening, so we're going to need 2 fraction bars. All right. And if we're putting things back, then we know this is independent probability. Okay, so we know that we started with 15, she puts it back, and we're going to have 15 again. But the first time she wants a red marker, how many red markers are there? 4. So she has 4 chances out of 15 to get a red. Then she puts it back. How many chances does she have to get a green marker? Well, there's 3 of those. Then again, I'm going to use Desmos and just multiply my numerators. 4 times 3, which is 12. Okay, and then I'm going to go to my next line and multiply across the bottom. We had 15 times 15, so I'm multiplying my denominators. So that's 225. Now, we're going to see if we can simplify this, and I'm going to show you the way that Amber and I showed you how to do this in class. There are many different ways to simplify, but this is just an easy way that everybody can follow. So you've got the numerator over x, the denominator over x, there's the 12 and the 225, and we always start with the numerator. So I'm going to put a 12 for x. That number has a decimal, so that cannot be simplest form. So let's try an 11. Nope. How about a 10? Because we're going down by 1. That didn't work either. 9, 8, we're looking for no decimals. 6, 5, 4, 3. There you go. So that means when you simplify this, the fraction becomes 4 over 75. To make sure you get it in simplest forms, you have to start with the numerator and go down by 1. That way you don't miss any. And the first time you hit numbers with no decimals, that's how you simplify. All right, so let's try the next one. Miss Wright has a box of markers that are all the same size and shape that she uses to write on the board. Sound familiar, doesn't it? She has 4 red markers, 3 green markers, and 8 black markers. So again, her total is 15. That didn't change. Now let's see what happens. Miss Wright is passing out markers to her students. What's the probability that she first selects a black, does not replace it, and then selects a red? Well, first of all, if she is not putting it back, that is definitely dependent probability, okay? Because the chances are not going to be the same. So we're going to have line equals line. So first we're looking for black. How many blacks are there? 8 out of 15. So she chose one and she did not put it back. That means now there are only 14 left in that bucket. All right. And this time she's looking for a red. What are the chances she'll get red? Well, 4 chances out of 14. So again, we're going to put this in our calculator. We're going to multiply across the top first. 8 times 4, which is 32. And then we're going to multiply, pardon me, I was in the wrong screen. Multiply by 15 times 14, which is 210. I got to get my marker back. Whoops. Thank you for being patient with me. Alrighty, that's 210. And then we're going to try to simplify. So just like we did last time, we take our top number, our numerator, and divide it by x. Then we take our denominator, our bottom number, and divide it by x. And then we take x equals, and we're going to start with 32, because that is our numerator. Okay, so we're going to go down, and we're going to try 31. All right, I'm just going to keep going until both numbers have no decimals. Okay, that's our goal. So let's see how far we can go down. As you notice, I'm just going down one at a time because I want to make sure I get the simplest form. And it so happens that, well, let me make sure I did that right. Let me go back to 25, and 24, 23, 22, 21. Oops, got to get 20. Nope, that didn't work either. Let's try 19. Always be careful like I did. I was down at 2, but that may not be the lowest, and I want to make sure I'm at the lowest. So 18, 17, 16. I'm just going down. Oh, there you go. Well, that didn't work either. Let me go down to 14. Or let me try 15 again. Yep, 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2. 2 is as low as I got. Alrighty, so that is 16 over 105. Okay. The reason I go down by ones is just to make sure that I have it in simplest form. Alrighty. Let's see if we've got another one. We do. Hector has 15 socks in his drawer, so that's the total, 15 socks. They're all the same size and shape, and he randomly selects a red sock, puts it on, that means he is not putting it back, and then selects a white sock. Okay. Are these events independent or dependent? Well, if he puts it on, then the number in the drawer changes. So that's definitely dependent probability. If he chose a sock and put it back, then it would be independent. But since he put it on, didn't put it back in the drawer, definitely dependent. Okay, let's read this one. Lee rolls a fair number cube, which is the same thing as a die or dice. Okay, dice is the plural. Labeled 1 through 6 2 times. On both rolls, the number 6 lands face up. Are these events independent or dependent? Well, they are independent because that number cube has the same number of sides every time he rolls it. Okay, so that doesn't change when you're using a number cube or a coin or a spinner. Anything like that, it is always going to be independent probability. All right, here we have something else. Let's see what happens. It says Eric and Sue will randomly select a treat bag containing 6 lollipops and 4 gumballs. Eric will select a treat, replace it, then select the second treat. Okay. Sue will select a treat, eat it, and then select a second treat. Who has the greatest probability of selecting 1 lollipop and then 1 gumball? So I'm going to split the screen here, and on one side we're going to talk about Eric, and on the other side we're going to talk about Sue. So first of all, in the treat bag there are 10 items. Eric is gonna select a treat, and then he's gonna put it back. So that means 10's on the bottom both times, okay? Let's see what Eric does. He's gonna select a treat, put it back, and then select a second treat. Who has the greatest probability of selecting one lollipop? So if we're going for a lollipop first, that's 6 out of 10 chances, and then a gumball, which is 4 out of 10 chances. So we're gonna come over here and do the math for that one. 6 times 4 is 24, and 10 times 10 is 100, so I'm gonna do 24 over 100. That's his probability. I'm not going to simplify it this time. I'm just gonna keep going and try to figure this out. And Sue, she tries to pick a lollipop first. There are 10. She has 6 chances to get a lollipop, but then she ate it. She did not put it back. So that means there's only 9 things in there now. And now she wants a gumball. So she would have 4 chances of that. So 6 times 4 is still 24, but 10 times 9 is 90. And it wants to know who has the greatest probability. So what I'm going to do is I'm going to take Eric's probability, 24 divided by 100, and I'm going to multiply that by 100 to make it a percent. That way my number is easier to look at. Then I'm going to take Sue's probability, which was 24 out of 90, and I'm going to multiply that by 100. So who has a better chance of selecting a lollipop and then a gumball? Okay, well, Eric has 24% chance and Sue has a 27% chance. So Sue has the greatest chance of getting one lollipop and then one gumball. Okay? All right. So that's all for probability. And if you have any questions, just let us know. We're glad to help.